Доброе утро, уважаемые коллеги.
Good morning,
Меня зовут Hannes Faluk.
distinguished
Приветствую вас
colleagues. My
не
name is
только от
Hannes
имени
Faluk.
Российской
I'd
германской
like to
внешнеторговой
welcome you
палаты,
on behalf of
где я
German-Russian
возглавляю Центр
Initiative for
информации немецкой экономики, но и
Digitalization
от
of the Economy
имени
on behalf of
Германо-российской
the
инициативы по
Chamber of
цифровизации
Trade and
экономики,
Commerce.
так называемый
And
GRID,
this is
German-Russian
so-called
Initiative
GRID
for Digitalization,
is
как вы
the
видите у
partner
меня.
of this event.
Дана ініціатива об'єднає
This
чотирьох
initiative
німецьких і
unites
7
4
російських
German and 7
високотехнологічних компаній,
Russian
а
high-tech
також
companies, as well as
Российско-германская внешнеторговая палата,
Russian-German
Восточный комитет германской
Chamber
экономики
of Foreign
и
Trade
Российский союз
and Russian
промышленников и
Union
предпринимателей.
of Industrialists and
Инициатива была
Entrepreneurs.
создана
This
в
initiative
2016
was
году.
created in
Ее основной целью
2017, and
это
its
обмен
key goal
опытом
is
и
exchange of
лучшими
experience
практиками
and best
между немецкими и
practices
русскими
between Russian
организациями
and German
именно по вопросам
organizations
трансформации
in terms of
Industrie
the
4.0.
transformation and Industry 4.0. Therefore, we have lots of joint meetings, joint events, both in Germany and in Russia. Also, we participate in large business meetings, like today at INAPROM. We appreciate this opportunity given to us by the INAPROM organizers, because we have this opportunity to have this session today. The topic of our today's session will be a scenario of using artificial intelligence technologies in industrial manufacturing processes, and today, and both today and in future. There was a recent publication in Forbes magazine, and machine learning and artificial intelligence were named as trend number 1 that determine the factors of future development for the next decade and even greater period of time. Everybody knows different examples of using artificial intelligence for virtual voice assistants, so-called chatbots and automatic translation services. And personally, I can tell that my best practices after 3 months of lockdown with my family in Pereyaslav, and I can tell you that our grandfather in my wife's family, the grandfather is 94 years old, and we presented him with Alice last year during Presidential Council of our organization was presented this technology, and we didn't know how to apply it. And at that time, Mrs. Bulmer told us that for children, for older people, this threshold, this barrier for communication with artificial intelligence is getting less important. And this, our grandfather liked Elisa a lot, and he continued communicating with Elisa, and he welcomed Elisa with good morning, good night, and Elisa was willingly answering different questions except for military sphere. But artificial intelligence technologies are currently used in manufacturing, and these technologies help us to make this manufacturing more agile, more reliable. They facilitate the work of engineers, the designers, the maintenance experts, and they help us to protect environmental manufacturing objects from hacker attacks. And these examples of using artificial intelligence in in manufacturing facilities, we will discuss this topic today with our participants from Russia and Germany. From German part, I'm pleased to present Sergei Karpunichev from SAP Company, and Mark O'Brien from Siemens, Alexander Borisov from Bosch Company. And Russian party will be presented by Vice President of the Russian Union of Industrialists and Entrepreneurs, Sergei Mitinkov. And Sergei, I would like to invite Sergei to be our first speaker today. And my first question is, how do you assess the relevance of artificial intelligence for development of Russian economy in general? And how do you think it can facilitate, promote digital transformation of the Russian economy? And what is your vision? What is the vision of your colleagues in your union?
Good morning, dear colleagues. Good morning, our dear moderator. Thank you very much for the question. But first of all, I'd like to say so that you concerned in your speech just in short about that situation. So about 3 years ago, we signed a very important contract between Russia and Germany, and we started the initiatives. And as you also said, that Russian companies have a great interest in joining that initiatives, and the dialogue which was between Russia and Germany, the exchange of technologies. You brought Russian entrepreneurs to Germany, and also you met German entrepreneurs in Russia to show them the manufacturing processes, not only in Moscow but in other cities, including Ekaterinburg and in our industrial cluster, Russian industrial cluster. As for the artificial intelligence, since the 1st of July in Russia started just the initiative when in Moscow it became the center to develop the platform for artificial intelligence, to develop some normatives and regulations. And I think it's not by accident. You gave such an interesting example about Yandex company. If you noticed, in the Moscow streets you can see a lot of cars which have symbols of Yandex. And we can see a lot of cars like that with that symbol. So, and it also said that so free pilot testing that we could see also in Germany, visit in Germany not so long time ago, and when we could see their German just technologies. And Russia is also interested in pilot-free transport and pilot-free technologies. And what is different from Germany, so now our cars in Russia could just go along their roads, which could be used by just every driver. So if I go back to the artificial intelligence, I should say that in Russia there are many companies which start and which make some ideas and suggestions how to optimize and digitalize business processes. And I think that later on we will see, we will hear some other ideas about other companies. But I'd like to tell now that Russian companies could show grow up due to the situation, due to the pandemic situation, and pandemic became a very bright just and very necessary driver for technologies. And one of the companies which I'm familiar with make an interface how to work between the employer and the employees, because there were a lot of questions how to work distantly, whether to be at home or not to be at home, where to go, how to just make sick leaves, how to just make holidays, leaves, and so on. And there just were a lot of suggestions which could allow the company of the medium and large businesses to make a dialogue with the employees to meet their needs and automatically just synchronize their applications with the accountancy department and manufacturing departments, and when every employee could ask the question and he could get an application form immediately and apply this form and send back. So such examples of very fast developing technologies which appeared on time during the pandemic could allow us to implement very new technologies. And alongside with all negative impact of coronavirus infection, we could see the growth of the high-tech technologies. I think that this is really very, very important. And secondly, another Russian company, which is also just the BRIC member, developed the application which could allow to manage printing. And that's also very important because when people work just distantly, sometimes they cannot understand how to print out the papers. And just here in that situation we can understand the price for printing, so cartridges and paper which is necessary to change and to buy. So, and it's very important that we have a Siemens company today. I'm very impressed by the plants in Germany which were fully automated, and I'm very pleased to know that we were shown the new technologies and that they were not afraid to show this and to demonstrate these new technologies. And when our delegates attended Germany, just a Russian delegation visited Germany and a German delegation visited Russia, we could just exchange technology and we could show all our best what we achieved for that time. And I really think that the topic for our audience and for our sessions is very urgent, and I will be very glad to listen to our other participants of our discussion.
Thank you, Sergey. It's really important to know that you are interested in these issues. Now, let's talk about particular cases when we can use artificial intelligence in manufacturing processes. And I would like to invite the next speaker. He is the head of discrete manufacturing SAP company for CIS, and I would like to ask you, how can we make the artificial intelligence a part of manufacturing chain, and how does your company incorporate these technologies and why? Thank you, Hannes. Thank you, Sergey, for your introduction. Basically, what is interesting, you gave us one example of artificial intelligence used in our regular life, and we understand that it happens because the development of humankind, what we do, we move towards technologies and we develop these technologies even further, and we use them in our private lives. And it's understandably that in order to produce more complex products, we need to introduce changes into manufacturing process itself, so that we could produce new interesting things. And we can also say that we are on the edge of rethinking this manufacturing process to be able to create such complex products like Alisa that you mentioned, or pilot-free vehicles. And this is happening because most manufacturing facilities are once created for mass production with minimal costs that would allow to get maximum performance parameters at minimal costs. But this paradigm is becoming the matter of the past because over time we have seen lots of substitute products, analogous products, because people are dissatisfied with certain parameters in a vehicle or in a radio device, a telephone, and therefore we see lots of newer devices. Traditional manufacturing facilities have to reorganize themselves in order to produce, to have their mass production and to be able to guess the demands from the customers that would allow them, that would become a trigger for the customer that would make him to buy this product. Therefore, we see a new paradigm which is called mass personified individualized production, because mass production is still there, mass consumption is still there. This level of consumption is even growing in certain areas. Therefore, in addition to mass production, we need to take into account customers' demands at this larger scale, because our customers have versatile, very diverse demands, starting from basic things like different colors and to different materials. Someone wants to use eco-friendly materials, others want higher technology products, and so on and so forth. What I'm talking about, we need to maximally individualize our solutions for mass production at the same time. But we have to preserve the basic costs, because we do not want to spend twice as much to produce one item of the product. And these three things come together, and we understand that it is impossible to fulfill these demands without technologies. If we talk about this particular case, it turns out that the use of artificial intelligence solutions become of paramount importance to determine the potential demands of our potential customers. And we regularly see some customer polls to determine their demands, to determine the strategy of the company 1 year ahead. And now we have to do it constantly, and artificial intelligence helps us to collect all these wishes and demands from our customers, to be able to realign the manufacturing processes, to transform, to make some changes in the design of the products. And our solutions are at the junction. There are lots of projects, ongoing projects in the area of artificial intelligence. But what is important here? The results of processing certain data should be applied properly, should be processed properly, so that manufacturing production chain and design processes and construction engineering processes should be made with full awareness of what should be done. We currently observe that in this particular issue there are lots of experiments, and these experiments often end up at the stage of prototyping, and we see no mass production. But I think the reason is that not very often we have some ideas that could be implemented, and not always these ideas, this full cycle is thoroughly thought. If we take another example, one of the most common issues today, the predictive repairs. And this is another issue. What if artificial intelligence systems could tell you that certain piece of equipment is going to shut down in 24 hours, let's say? What should we do with this information? If our system, our platform, when gets this data and processes them in proper way and interprets this information in proper way, and to assign certain service teams, to assign certain resources, to order some parts and components for this repair, and so on and so forth. Then, and this system might even help us to reconsider the manufacturing processes in terms of future repairs. If something is broken on somewhere between the different cities or towns, and we have to arrange supplies of the raw materials or services, of maintenance services, and in future this data about repair, and we have to analyze the circumstances, the terms of use, and we have to analyze this data to make some changes at the design stage. And in particular, when we create these innovative projects with our customers based on artificial intelligence, we try to foresee what is going to happen next when we see some kind of failure, equipment failure or deviation. You know that artificial intelligence is successfully used for maintenance and servicing of railway equipment, and artificial intelligence is now used to detect some failures, and we were able not only to find methods how to trace those failures, we gathered necessary indicators and parameters, but we also changed the process of repair. Somewhere we changed the procedures, we switched from operational hours into quantities of door opening and so on and so forth, and some other parameters that are more sensitive for tracing, and based on those parameters we can conclude what is going to happen in the nearest or more distant future. Sometimes we can increase the service intervals, and finally, when these change, the entire process has been changed, then we can tell that the costs, the repair costs, decreased by 8 to 10%, which means dozens of millions for a company. Therefore, when this end-to-end process is created using the artificial intelligence with all the supporting systems, it can be really effective. Another example that I would like to give, it is interesting and it is getting more and more relevant because we see such a demand from many of our customers, and we have machine vision projects, with lots of machine vision projects with our clients. The thing is, we all are, and I would like to give you another example, that when artificial intelligence can improve the quality of the manufacturing process, of the quality of the finished product, and using computer vision, machine vision, what we have, there is some assembly line, and when some product is being assembled, there are certain chains of details that need to be assembled along the way. Uh, and traditionally, we see some employers, they suspend certain details within this assembly line. And as the product moves over this assembly line, these components are added. And sometimes we see mistakes when wrong details are put there. The angle of 90 degrees or a different angle is 80 degrees, or some distance is greater or lesser. And people can make mistakes and use some wrong details, some wrong parameters. And in this respect, computer vision, machine vision detects what this detail component is. It can measure all the parameters, distances, colors, angles, other parameters, and it can determine that this detail corresponds to this product and it needs to be suspended at this moment, and it improves the quality, the rhythm of the pace of the manufacturing process. And this example is really relevant today, and it is common. Another interesting thing about machine vision, we can prevent failures. For example, when we extract ores, we extract raw materials, and there is moving line, which goes into the grinding machine. The raw material goes into grinding machine, and sometimes there is some piece of metal from the equipment may go into this raw material. It may end up, and the grinding machine the crushing machine could break. And this machine vision, with proper settings, with proper location, can detect some foreign materials in this or raw material, and it can tell you that we should stop this line and we should remove this foreign body to prevent the equipment failure. And these examples are numerous, and throughout the life cycle of the product, now we have this opportunity not only to look at our customer testimonials, but the product itself can tell how it works. It can self-diagnose itself. It can send this data to the manufacturer so that we could predict that something is going to happen with this product. And artificial intelligence is key source of this information, which can be processed, and it can be helpful to operate to use this product without any deviations or failures. Thank you, Sergey. It was very interesting. I see that we have a couple of minutes for a short question. I have such question for you. Before the COVID lockdown in March, at the end of February, I visited the Silicon Valley. I visited my colleagues from the Chamber of Foreign Trade, and they invited me, and I got familiar, and I looked at and we visited this innovation hub of the SAP, which is close to Tesla. I think that you have 3 such hubs in Moscow, in Silicon Valley, and in Singapore, if I'm not mistaken. And we were shown there some prototypes for manufacturing processes, and it was really impressive for me. But and they were with great respect, they were talking about not only artificial intelligence, but about human intelligence, which is there in Russia. Because the headquarters of your company is in Russia, and there are lots of talented designers, engineers, and I'd like to ask you, how do you estimate? What is your opinion about it? And also, one philosophical question. If we talk about the prospects about 10 years from now from Forbes, can artificial intelligence save us from our own intelligence? Well, regarding your first question, Here, our innovation hub is located very close to other companies, and I personally like learning new things, and I like to look at what is going on. And what I think is, even if it's really important in terms of learning, and I do invite everyone to visit our laboratory to get familiar with what we do, what can be done in these innovative areas, in the area of artificial intelligence, what people are experimenting with. And the driver is not only the internal brain of SAP, not only our employers, but also our customers. And in this respect, we use various methods of joint efforts, joint work. When we develop different innovations, when we develop something new within our company, and when they need some outsourcing, some advice, pieces of advice, the other companies approach us, and sometimes they offer organizing joint laboratories, and we collaborate with those innovation hubs, and this is like a bridge between Russian developments and Russian information laboratories and other laboratories all over the globe, and they closely communicate with each other in terms of experiments in different sectors of industry. How, for example, artificial intelligence can be used in the sphere of insurance, in fiscal area, how we can prevent some insurance events. And in this respect, it's really interesting to use artificial intelligence. Regarding the future prospects, whether people will get less smart than machines, I don't think that it could happen, simply because what we see now, people create assistants in those areas where they feel some weaknesses. For example, computer vision, machine vision. It is really better to learn something. Sometimes it's easier to learn something new instead, some new profession, instead of doing some mechanical work which can be delegated to machine vision. And this is just one example. And humankind is developing. There is some progress, and over time, I think that machines will be smart enough. But we haven't yet discussed this issue. But we have to remember that machines could share some risks and responsibilities with humans, risks for certain mistakes that were generated by artificial intelligence. This is one of complex issues for pilot-free driving. These things do happen, and artificial intelligence is going to develop, is going to grow, but I believe in bright future of the humankind. I think that everything is going to be okay. Thank you, Sergey. That was very interesting. Dear colleagues, now I invite us to discuss the first step of any in manufacturing process, the stage of design and engineering. Marco Pry is with us. He's responsible for the strategy of Siemens in Russia, Belarus, and Central Asia.
Thank you very much, Hannes. As was mentioned before, artificial intelligence is already used widely today during the operation and production phases, where usually you look for optimization potential. Now, when we go back all the way in the product life cycle to the very beginning, I will show you a few examples today how it can also enhance the creativity of engineers and help us to develop optimized products from the start. This concept we call generative engineering, and that is basically the combination of artificial intelligence with physical simulation and engineering expertise. All this functionality is not just an idea, it's already available within the software packages of Siemens. You can buy our SimCenter software and you can start using it today. I will show today a few examples from the automotive industry, but of course, this is valid for all industries that produce smart products. So all the way from smartwatches up to aircraft and spacecraft. So why is this so necessary? Why do we need artificial intelligence in order to create products? The reason for this is that the past few years have seen a huge explosion of complexity of products. It means that if you look at cars, while maybe 20 or 30 years ago, the main focus of innovation was to have the best combustion engine, today it has completely turned around. 80% of today's innovation in cars comes from software. That means suddenly you have smart systems everywhere. Even a small mechanical component like the side mirror that was probably one of the cheapest spare parts a few decades ago is now a highly complex system of cables, sensors, cameras, and such stuff. And of course, this is just one example. What adds to the complexity is that we have today new manufacturing methods, new materials, 3D printing of all kinds that also enable new shapes and new functionalities. And on top of that, we have all those trends like IoT, car-to-car communication, cloud technologies that are also integrated in those cars. This gives complexity, and unfortunately, it's not possible to reduce this complexity because that would give away the potential for innovations. So we have to manage this. And for this, we use artificial intelligence from the start in order to be able to integrate everything into good products and into having them produced within short time. I will give you one example why we need this more concretely. Let's look at a very recent type of vehicles that has been produced for a few years now, and that's a hybrid electric vehicle. This is, of course, challenging to generate because this kind of car includes two different cars within one. So basically, you have an all-electric car and a combustion vehicle combined. So, of course, the challenge here is that you still do not have more space in the car, and it should also not weigh more, and it should have the same parameters as a usual car. So how do you squeeze all that additional equipment into one car? You could imagine that for such a hybrid architecture, you have a lot of options. Just the question how to combine a combustion engine, the electric motor, the transmission system, the suspension, the battery storage. We estimated that there are way more than 1,000 possibilities to create an architecture involving all this. Of course, it's never possible if you are looking at normal engineering processes to try out all options by yourself. Yeah, maybe if you're good and fast, you can try out 10 of these varieties, but certainly not 1,000. So that means that in this whole design space of potential architectures, there are almost 1,000 that you have never looked into. And maybe the best one is among these that you haven't checked. So you need some kind of automated process to help you to get to this optimized architecture for electric cars. So this is just a short overview how this process works, how artificial intelligence would today assist an engineer when he would create a hybrid electric car. So, of course, the very first step of the process is the engineer himself or herself. He needs to find out and define what kind of project should be in the end. Yeah? So in that case, there are a lot of constraints and a lot of rules that need to be given to our SimCenter system. basically very simple things like the car should have 2 axes, and there are certain types of motors available and components that can be used, and maybe some other restrictions like the weight of the vehicle itself. This the engineer puts into a one-dimensional model, and with this model we can then start working with our artificial intelligence, with generative engineering methods, because then our software generates all possible architectures and configurations that fulfill this set of rules. So exactly this thing that you would not be able to do yourself manually, the system does for you. So that is the first step of our artificial intelligence. The second step is, of course, once you have these 1,000 or even 1,500 architectures generated, you need to evaluate them. And again, this is not possible to be done manually. Again, here the system helps by using machine learning, by using reasoning and functional analysis to rank all these architectures according to the KPIs that you set before. So, of course, for every car, the set of KPIs can be different. Maybe you want to optimize for maximum efficiency. Maybe you want to have the fastest car. So all these factors play in, and in the end, the system gives you, in this case, the 3 optimal configurations, which you then can further analyze and test. So the main benefit of this is that, first of all, using artificial intelligence, you can look into all possible options that are available in the design space. And second, you will get an evaluation from the system itself without building prototypes, without testing in the physical environment. So after this design process, you already know what is a good optimal configuration for this hybrid electrical car. Let me give you a second example. It sounds maybe a little bit primitive, but it's not. It's the question of where to put the cables in a car. If you just look at those 2 images on the screen right now, there you see 2 different cars and their cabling. The left one is an electrical car. It's a Chevrolet Bolt. And on the right side, you have an autonomous electrical car, a Chevrolet Cruze. So from the type of architecture, they are very similar. Just the right one is autonomous. And of course, an autonomous car needs a lot more cabling and wiring than any other car. And here the challenge is again twofold. So first of all, you have a lot more cables, but not a lot more space. You just have the same amount of space where you need to put everything. And the second challenge is that these cables are very high, that they produce and transport quite high current and communication data. So you also need to make sure that they do not interfere with each other in any way. And again, you want to do this before you start building a prototype. You want to know if the cables are in the right place before you even start sending cars out on the street. So again, the way to do this is with generative engineering. In that case, the solution would be you first create these wire harnesses with our Capital software, and then again you export them into our SimCenter suite, where you get all these generative engineering functionalities. And this system will then run analysis for you. For each and every cable, it will tell you, first of all, whether there are any interferences with other cables, whether it's optimally placed. And in the end, you will get 2 types of results. So first of all, you could get the result that says you need to shield this cable better because it gets electromagnetic interference from another cable. Or a result would be you need to reroute this wire to through some other place in the car. So as I mentioned, all these technologies help you to be faster and more reliable in the design of smart products. Of course, there are plenty of other opportunities how you can further use generative engineering and artificial intelligence. For example, we give you with our pre-scan software, we give you a software that lets you completely virtually test all kinds of driving situations for autonomous cars. You will get this generative engineering also integrated in our CAD software and in our fluid dynamic simulation software, all to be able to use it to optimize shapes, topologies, functionalities at every stage of product design. So in the end, it helps you to be fast and to have innovative and reliable products. Now the question is, of course, why is this so relevant for the Russian market? So we've seen in the past years a huge story of increasing the global competitiveness of Russian products. Russian products are increasingly made for export to all countries in the world to compete with other products. And that means the innovation process and the design process needs to be fast in order to catch up with the rest of the world and in order to fulfill the expectations to quality of products. And that is precisely why we hope and we expect to see more of this technology applied also to products that are created and produced in Russia.
Отлично. Марко, большое спасибо за эти наглядные примеры.
Thank you very much, Marco, for such examples.
Мы чуть-чуть уже задерживались. Я не хотел вас перебить. У нас еще, может, минутка есть.
But we have about a minute.
Хорошо.
Well, then we are going to continue.
Sorry, was there a question? I did not get a translation so far. So could you please
in our
repeat?
next report, we will discuss quite enough issues for every industry concerning information safety, information security. We all remember when cyber just killers. They made some attacks at big, large-scale objects in the Internet of Things. And our next speaker, Alexander Borisov, is the head of the Research and Technology Office in Russia, Bosch. Alexander, could you tell us, please, how the companies could use the artificial intelligence to protect their industrial infrastructure for such attacks? And what experience does your company have? Thank you very much. Good afternoon. Really, we actively implement artificial intelligence in our practice for just the protection of our products and for developing the new products. And I could give you some different cases. In principle, it's very interesting to look at how the landscape look like, so of possible hacker attacks and how we can protect from them. And here it's very important to understand that our world has been changing very fast. So everything is becoming to be computers. So we have computers with monitors. We have computers just on the planes, and we have computers on the wheels and automobiles. So everything is computerized. And we have very many different systems which are similar to each other on the one hand, and they can be widely used. And the number of the computers and its power is different. And what is really very important when we think about security, and about defense, we should understand what is the balance between the attack and defense systems. And always during the decades, so the attackers are more in number than defenses. So if we look, for example, at the historical battles, such paintings just in the medieval age, so the troopers attacked the castle, and so the ratio should be 1 to 4. So attackers should be better equipped than defenders. Of course, so they should be tested beforehand, and to just to test the equipment which is used during the battle, but during the attack, so it's easier to defend than to attack. So if we look at the literature, for example, about war, we could see that to attack is more difficult than to defense. So it all concerns the middle or the beginning of the 20th century. Then the situation has changed a lot, and we could see such American equipment. So 10-15,000 people, several billion in investments, but just the defects, which is huge, and so we couldn't really imagine that it could demolish everything like a big country. So, and it becomes very serious from the point of view of the balance. So, and to defend is very difficult from such attack. And what is even more difficult is just under water boats, submarine. So if the boat is in the neutral waters, so and the investment are of several billions, then it could attack a lot of people. So the balance has been changed a lot. So, and we can understand how much is spent for the defense and how much is spent for the attack. But if we look at the modern sphere, IT sphere, then we can understand that, of course, one hacker or a little group of hackers can attack big industries. And, for example, they can attack such companies as Volkswagen and other big companies. So a couple of years ago there was an attack on a Volkswagen company, so and there were billions of losses. So and you can even imagine the paradigm, so that just the disbalance that we could see now is even more. And the one famous scientist, the theoretic and practice, says that just on the internet attack is easier than defense, so that attack is easier than defend, and this is a very new concept which appeared recently, and we have to do something with that. And as we could see, that one of the factors of the defense is the use of artificial intelligence to make everything easier and faster to detect different vectors at the industrial processes and to resist that attack. And this is our goal. The goal of Bosch research is to change this balance and to make Bosch plants the most secure plants in the world. And there is such a pyramid consisted of 3 sectors. So there is a research department, so the development department and the production department. And the production department produces just the products and services, a lot of plants everywhere in the world, and they produce some products which can be bought just in the shops and somewhere else. And the second block is the development. And one more block is the research block, which develop the products which the customer could see in one generation. So we should foresee just what will happen just in the future, and we should understand how the production will look like in the future. Of course, there will be less humans and more artificial intelligence anyway, undoubtedly. And it's very important to understand all this cycle, all the production cycle. Normally, there is the development of the product, and there should be used some mechanisms to make this product reliable. And a good example is secure coding. We try to develop the product just to have less mistakes or to decrease the number of mistakes. Then the next stage is integration. So there are some components, and then they are integrated with each other at the second step. And this is very important to make it simple and reliable. The third block is just the usage of the product, use just the industrial capacities to make, for example, the vehicle. And the intellectual artificial intelligence is very important to recognize some defects. And some just wrong products could be demolished. And I'd like to emphasize also the phase how to detect the defects and anomalies. So during the seconds we get some gigabytes of information, and humans of course cannot handle this information. They cannot recognize such huge data. That's absolutely impossible for humans, but with machine learning we could recognize, if we teach these machines, so we could recognize these defects, and we could recognize different signals and recognize some anomalies. So here we could see 3 attacks, and our neural networks revealed that and showed to us so that there were 3 attacks which we could never recognize only by hands, because there is a lot of information. So in that case, we are only testing this system, but we hope that in the next year it will be used worldwide. And what I'd like to say is that our world has been changing so fast, and now it's more difficult to defend than to attack, and artificial intelligence should be necessarily used. And to recognize the defects, we would use more and more artificial intelligence technologies. Thank you very much to Alexander. Thank you very much, colleagues, for your reports. And I think that we could see and we could hear a lot of interesting and useful examples. And to tell the truth, I also have a lot of questions which I'd like to ask you about, but we are short in time, and anyway, I'm sure that we could meet each other during some other different events. And as we all can understand, artificial intelligence will be one of the most important technological trends in the 21st century and in the 20th years. And in our office in Moscow, and I'd like to wish you great success. Thank you very much to the organizers, and thank you very much for participation. And I'd like to mention also that our organization organization holds many business missions, also on the topics concerning additive technologies. And here we are glad to cooperate with you, and we are glad when you join our events. Have a good day, and see you just later. Thank you very much.